Now, when it comes to polygons, we often measure properties of the polygon, such as what we call the perimeter, the area, and so forth. And just, to go ahead and fill in the blank in the packet, the perimeter is the sum of the lengths of the sides of a polygon, or just a figure in general. It's how long is the line that encircles the shape, again, assuming it's a closed curve. Now with a circle, though, the perimeter, which is again the distance another way to think about it is how, if I was to walk around this shape, how much distance would it take for me to cover the whole thing? Or if you were to sort of unpack it into a straight line, what would be its linear measure in that case? Where the circumference is a specific name for the perimeter of a circle. Now, if you call it the perimeter, that's the same idea, so it's not wrong, but it's just more specific and precise for a circle in general. And you probably remember there's a formula which has to do with the circumference of a circle, which is the formula C is equal to 2 pi r for circumference. A formula you should generally know. And it just basically there's a particular reason why this formula is true. And I wanted to talk a little bit about pi, but pi is a number you're probably familiar with. It's fairly culturally popular number, but it's approximately 3.14159. It's an irrational number. An irrational number means it is an infinitely long decimal number, kind of like 1.33333, but it is not repeating. There is no repetitious pattern behind it. And another thing, if you remember from last semester, is any repeating decimal can be written as a fraction, and fractions are called rational numbers. So if a number is irrational, that means that there is no way to write this as a precise fraction. And really what it means is it's kind of a complicated number. But if we actually think about, pi, I want to talk a little bit about pi. And it's been known for thousands of years that circles and lines have kind of a strange relationship. But if you think about a circle, let's say that it has a diameter of 1 foot. So imagine on a car, a foot, it would be a pretty small and diameter just means the width of a circle, which is twice the radius. Remember, the radius is the distance from the center to the outside. So in this circle, the radius would be a half of a foot. But anyways, imagine on a car, you have a tire, which is about a foot diameter. It's a pretty small tire, but some people have those little tiny wheels for some reason. I don't really understand why they like that, but it's a thing. But anyways, basically, if you're wondering, how long, imagine there's an ant that walks around the very edge of that tire and goes all the way around. How far of a distance would that be? How far did they travel? Obviously a relevant problem historically due to wheels and, construction involving circles and engineering and whatever. But early man approximated to be, they thought it might be close to 3 or fraction 22/7. There was a lot of numbers that were hypothesized to be this, but over time we've come to learn that it is a very precise number, which is very, very strange in terms of our normal numeration system. Being an infinitely long decimal is kind of a confusing thing, but essentially it's not a direct ratio of 3:1 or 4:1. A circle has a precise ratio of its diameter to its circumference. That is what pi is. So that ant, if it walked around a circle of that tire with the diameter of 1 foot, would have traveled exactly pi feet, which is, it's not 3.1, it's not 3.14, but it's a very weird number. And essentially the ratio between these, it's not 3:1. It's not something which is very easy to understand. And a question might be, why is this such a weird number? But you could put, I guess the simplest answer is it just kind of is. There is this weird relationship between circles and lines, which you could attribute to divine design or whatever. But it's a very fascinating relationship that it is because it is. And if we use a different type of number system, it might be less weird, but that's a whole different thing to think about. Anyways, so why is the circumference 2 pi r is another thing I wanted to mention. But essentially, if you think about usually circles are defined based on the radius, which is half of the diameter. But basically, due to the similarity, if I was to make a larger circle, let's say it had a radius equal to x feet, well, then its diameter would be 2x, because it's twice the radius. And again, the ratio between circumference and the diameter is pi to 1. This is a fundamental relationship that just is because it is. And so if you're thinking about, well, if the diameter is twice the radius, or I'll just write that as 2r to keep it consistent, well, then the circumference would be 2r times pi, because this one is 1 to pi. So again, if we're thinking about proportionality, it would be, well, this is to this, this is to this. But basically, you just magnify it by pi, and that's kind of the short reason as to why circumference of a circle is 2 times pi times r. And also, you could think about, well, what if we were talking about what's called the length of an arc of a circle? Or a circular sector is like, say you divide up a circle into pieces or into fractions. Well, if we take part of the circumference, that's sometimes referred to as an arc, or the arc length. And let's say we wanted to know what that would be. But there's a formula for that as well, which is basically if we were to take the entire circle and divide it up. Because an entire circle will always have radius of 2 pi r. Now, if we simply multiply by the angle in radian mode, basically that's what it will do. Because if you remember, we talked a little bit about angles and radian measurement 3 or 4 weeks ago. But remember that radians are defined to be the angle. Like, actually, if you have an angle in radian mode, all you need to do is multiply it by the circumference. Well, that's not entirely correct, but let's look at the formula. Let's say that we have an angle which is in degree mode. And remember, like, let's just say we're imagining this is like 160 degrees or something like that. Well, you could always think about what portion of the circle is that. Because basically the full circumference would be 2 times pi times r. And 160, if you divide that by 360 degrees, this would give you a particular fraction of the entire circumference. And so if you multiply that out, that would be, well, 16 over 36. And basically, you would just multiply that by the entire circumference, 2 pi r. And this would give you the arc length of the circle. But notice what's happening here is, in general, this could work for any angle. And if you just multiply by 2 pi r, well, that would simplify to multiplying by pi r divided by 180. So this is kind of the sensibility behind this formula. But let's look at an example. So it says, find the arc length of a circle with diameter 10 meters. So imagine you have a big old circle here where the diameter, basically the width, which is just called the diameter in a circle, just to say it once again, pretend this is a nice perfect circle, is 10 meters all the way across. So imagine a giant circular swimming pool, and we want to know, and actually, sorry, I forgot to give an angle here. If we want to, let's just say that this is circumference, and then let's just say arc corresponding, let's change this to circumference. So there's a bit of a typo here. Corresponding, whoops, to theta is equal to, let's just say 100 degrees. Okay, sorry, I got derailed because I forgot to put one of those details in the packet. But let's start with the circumference. So the circumference of the pool in this case would be 2 times pi times r. So also remember here that the radius is half the circumference. So here we'd have 5 meters. So I'd have to do 2 times pi times circumference. Or another formula you may have seen is, well, the circumference is also sometimes written as circumference is equal to pi, circumference is equal to pi times the diameter. It's an equivalent formula, same deal, which, because the diameter is just twice the radius, it just means the exact same thing. And another way to remember this is that pi is defined to be the ratio between the circumference and the diameter of a circle, just an alternatively solved way of writing this formula. Again, as I was saying, that's just always this fundamental ratio, as I was saying before. But anyways, the circumference would be twice times pi times 5, 2 pi r. Or again, if you just take pi times 10, that's the same deal, right? Because if I magnify by pi, that just is what it is. So we'd have circumference is equal to exactly 10 pi. So a lot of times we even leave measurements involving pi without even calculating its approximated value, kind of like a variable 10x. Because it's actually simpler. Or obviously I could multiply 10 by 3.14, the approximated value. And again, because that's not an exact relationship, this would be about 31.4 meters, because pi is about 3.14. To give us an idea of, well, say we wanted to walk around this pool and wanted to know how far it would be, that would give us an approximation. Now, let's say that we have, instead of a full pool, let's say our pool is what's called a circular sector. It's not the full thing, but it's just a particular part of that corresponding to an angle of 100 degrees. And so we're looking at this component instead. We want to know what's the length of that particular arc. Say if I was to walk just around that portion like that. Well, again, you could basically figure out, as I said before, you can figure out, well, what fraction of the whole circle is it? And since a whole circle is 360, you just do it that way. Or, again, you could just use the formula. And that's always the simplest way of solving a problem. But in order to use a formula, you have to know the formula. And the reason why going through this, I think, is important is it helps us understand why the formulas are true. And once you really get it, it's something that you don't really forget. Or if you were to forget it, you could always kind of use simple reasoning to figure it out once again. But basically, I plug all those in. And notice that since the degrees, I talked about this a few weeks ago when we were talking about degrees, but it is a unit. It has a unitary measurement to it. But it's important to note that the degrees would actually cancel each other out and leave us with the measurement which is in the original problem. And another thing to notice about this is because the radius is measured in meters, notice that the answer remains in the same unit. And you want to pay attention to the variables and formulas in terms of how the units come across in the answer. But in degrees here, degrees will cancel, and then since this is in meters, this answer will just be in meters as well. So what I would have as well, 5 times 100, so that would be 500 divided by 180. So that would be 50 pi over 18 meters. And again, I could do this as an exact measurement. I could even reduce those by 2 down to 25 over 9 pi meters. Or of course, just type it all into a calculator to approximate the decimal value of that. Pi times 5 times 100 divided by 180 gives me approximately 8.73 meters for the arc length of this particular portion. And it should, your answer should always make sense here, where if this is 5 meters, then going around it looks like it's going to be a little bit more, right? And so, 8 meters, that makes sense. And the distance all the way around, 31 meters, again, makes sense based on the fundamental ratio of pi and what it means.